That's what our universe looks like if you look at it through a device that detects microwave background radiation. The blue color indicates low temperature areas and orange high temperature. But what is this strange line here? Scientists call it the axis of evil. It was noticed in satellite images back in 2005, and since then, it's become a nightmare for the scientific world. Some researchers believe that the axis of evil doesn't exist. Others believe it'll change everything we know about space. But most scientists are simply frightened by it. In this video, you'll find out, why is humanity a statistical fluke? Where is the center of the universe? And why are scientists so concerned about the axis of evil? How is the axis of evil related to the center of the universe? Let's look at this image once again. What can we see here? Stars? Galaxies? Not really. This is the cosmic microwave background, or rather the echoes of the Big Bang. At the stage of birth, the universe was filled with hot plasma. But over time, in the expansion process, it cooled down to 3,000 kelvins and atoms began to form in it. Scientists call this period the epoch of recombination. When the universe was 380,000 years old, there was more space between particles, and photons could then move freely. It's these photons, or relic radiation, that we see in this picture of the universe in the microwave background. In fact, this is an image of what our universe was like 13.7 billion years ago. And here comes the most exciting part. Scientists reasonably suggest that the cosmic microwave background radiation should be homogeneous. No matter where we are in space, we'll observe the same pattern of radiation, which means an equal number of blue and orange areas. The universe doesn't have any direction or center, so it must be the same whichever way you look at it. Most of our knowledge about space is based on this, and it's this theory that the mere existence of the axis of evil disproves. But how can the universe be homogeneous if it contains stars, planets, and other clusters? And not only clusters for that matter, but also voids. For example, the largest of them, the Eridanus supervoid, basically occupies about 11% of the observable universe. Do you know how scientists explain the existence of galaxies and voids? Statistical fluke. It's believed that on the scale of the universe, such clusters of matter look like minor deviations from homogeneity. But is this really true? Initially, at the end of the last century, scientists suspected that the universe wasn't homogeneous. In 1989, NASA launched the Cosmic Background Explorer, a satellite aimed at studying the CMB. But the COBE instruments weren't powerful enough. And although the collected data was enough to suspect a slight inhomogeneity in the cosmic microwave background, scientists needed more proof. And in 2001, COBE was finally replaced by another more modern probe called WMAP. Its instruments allowed it to capture a clear image, literally. Analysis of the data collected by the probe showed that the universe is, in fact, inhomogeneous, and there's a specific pattern to that. It turned out that there are inhomogeneities and deviations within relic radiation, and they line up along an invisible line. João Magalhães, professor at Imperial College London, called this line the axis of evil. But the WMAP probe didn't answer all the scientists' questions. Moreover, some still considered the axis of evil a mere mistake, so they needed another mission that would finally dot the I's and cross the T's. In 2009, the European Space Agency launched another spacecraft to study the microwave background radiation, the Planck telescope. It was equipped with two receivers, a low-frequency one with a range of 30 to 70 gigahertz, and a high-frequency one with a range of 100 to 857 gigahertz. Both instruments cooled down to a temperature that was only 1/10 of a degree above absolute zero. This let the telescope give scientists an even clearer image of the CMB. In 2013, scientists analyzed Planck's first data, and it turned out that the axis of evil hadn't gone anywhere. But the European Space Agency researchers weren't satisfied with this answer. In 2016, a team of scientists from University College London and Imperial College London once again analyzed the data collected by the Planck telescope over 4 years of operation. This time, a supercomputer was used for the analysis, and the scientists were finally able to relax. According to the results, the probability that the universe isn't homogeneous and the axis of evil really exists is only 1 in 121,000. But don't get upset right away. It's not the end. In March 2022, the space-based Chandra X-ray Observatory frightened scientists once again. It studied 300 clusters of galaxies and found that their brightness is very different, although they're at the same distance from Earth. This could mean that the universe isn't homogeneous and is expanding unevenly. So, scientists will have nightmares again. But why are they so afraid of the axis of evil? Scientists build up their theories about space based on the fact that the universe is homogeneous. But what are these theories, and what will change if the axis of evil really exists? Most likely, we'll have to completely forget about the Big Bang Theory. The main point is that during the Big Bang, our universe didn't shatter into pieces like after a usual explosion. Each area of the universe expanded separately and equally. So if the universe isn't homogeneous, the Big Bang Theory doesn't work, and scientists will have to look for a new explanation of where everything came from. But that's not the worst part. The speed of light may also change for us. After all, relic radiation is photons, particles that move at the speed of light. What if we see dissimilarities not because of a defect in the universe, but because the speed of light isn't as constant as we thought? But most importantly, if the axis of evil really exists, scientists will have to rethink 90% of existing knowledge about space. Can you imagine the amount of work to be done then? What would you do if you were a scientist? Would you work 24 hours a day, 7 days a week, just because a telescope captured something? Or would you ignore the new discoveries so there's no need to redo everything? Write in the comments.